Are your Android builds chaotic? Are diffs time to stop doing things manually and start shipping quickly and confidently with CI/CD. Our next speaker will teach you the fundamentals of continuous integration and walking you through creating a full CI/CD pipeline for your Android using GitHub Actions, from automating tests to deploying directly to production. Please welcome Ali Mansour as he presents Ship It Fast CI/CD GitHub Actions.
Hello, everyone. I'm really excited to be with you today. We are going to talk about how to ship Android apps faster and more confidently using CI/CD and GitHub Actions. My name is Ali Mansour. I am a senior Android engineer, graduated from the GDE Academy first cohort, and I love helping developers automate workflows and speed up releases. I create content, workshops, articles, open source, and today my goal is to simplify CI/CD for you. Let's start with a familiar pain. Manual builds slow us down. Tests get skipped when deadlines are tight. Signing and releasing takes too much time. And inconsistent release cycles hurt the product. CI/CD solves all of this by automating everything between code and release. Let's break it. What is CI? CI represents continuous integration, means every commit gets built and tested automatically. CD means continuous delivery or deployment. It means packages your app and signs it, and optionally pushes it to the Play Store. Together, they create a smooth, reliable pipeline. GitHub Actions is built right into GitHub. So there is no additional setup. It's free for public repositories, and the Android ecosystem is very well supported. It's a perfect choice for automating mobile workflows. As I mentioned here, it's totally free for the public repositories. You have about 2,000 minutes per month for free as a free quota from GitHub Actions for the public repository, for the private repository, sorry. And all the public repositories can work using GitHub Actions totally free. And regarding that, I will mention a workaround to work on public repositories totally free. In this session, we will cover CI/CD fundamentals and build a workflow together conceptually, automate build and test steps, and talk about deployment basics, and finally understand how to secure your app secrets. This talk doesn't need a complicated setup, just a basic Android and Git knowledge, besides a GitHub repository and a plain console account with Google Cloud account to create the service account to support deploying APKs or bundles to the Google Play console. Let's begin with the foundation. GitHub Actions works through something called workflows. Each workflow contains one or more jobs. Each one of these jobs runs on a runner, which is a software pretended as a virtual machine to run this job. We use the YAML language to create workflow files. Some people consider YAML language as an upgrade to JSON that focuses on the human readability. So this is the basic difference between YAML and JSON. JSON is created for the computer, and the YAML is the next version because it focuses on the human readability. The indentation matters in YAML, so take care of that. By understanding these four building blocks, that makes the whole system predictable and flexible. A CI workflow triggers automatically on a commit, pull request, or a tag. It builds your project, runs tests, it checks quality, and gives you instant feedback. This improves code quality and team velocity greatly. For CD, the workflow handles app signing, storing secrets, and optionally deploying to internal testing or production. Even automating only internal builds is a huge win here. I think you agree with me regarding this point. Never put key store files or API keys in your repository. GitHub lets you encrypt secrets inside the repository settings, and they become available only during workflow executions. This keeps your automation both safe and professional. To automate delivery, you can use the Play Developer API. This pushes builds to the internal testing track so your QA or testing team gets new versions instantly and no manual upload needed. Now, let's walk through what a basic Android workflow looks like. This is your simple CI setup. It builds your project automatically on push. Here we found the name of the workflow. Here our workflow name is build. And in the second line, we created or we defined the trigger of this workflow. This workflow will trigger on push. Okay. And we have here one job runs on the latest version of Ubuntu operating system. We defined that by setting this command runs on Ubuntu latest. So we configured this workflow to run on the latest version of the Ubuntu operating system. And also, this workflow contains one step to check out the repo code and fetch all commits in the Git history. What means here by fetch that's zero, we tell the workflow to get the entire history of the Git commits. We will use a small demo app called My Tasks. It's intentionally simple so we can focus on CI/CD without being distracted by the project complexity. These are the screenshots of the app working in action. The first second contains a list of tasks, and the second screenshot contains the new task screen. So from this screen, we can add a new task. And the third one contains the details of this task and contains two actions, the task update action and the task delete action. And the last screenshot contains the update task screen. From this screen, we can update the content of this task. This is where everything comes together. We will break down creating the YAML file, setting up Java and Gradle, running unit tests automatically, signing the app using encrypted secrets, uploading build outputs, APKs or bundles to the Play Store, making the pipeline fast using caching. All of this gives you a real production-ready workflow you can use immediately. Now, let's walk through the real CI/CD flow. We start by creating a YAML file inside .github/workflows path. This is the directory we will create in the root directory of our project. And first, we define the triggers, maybe on every push or pull request. In this example, I choose pushing a tag starts with a small v. For example, if I push a get tag uh, v 1.0.3 represents version 1.0.3, this get tag will trigger this workflow and it will be executed automatically. So the first line here, we created the name of our workflow to be easier to review the execution of this workflow in the history. We named it deploy to Google Play. And run name, here we defined the run name of this workflow, deploy to Google Play, space hyphen space, GitHub.ref name. So we here can review the execution. We can review what is the trigger of this workflow. For example, if the trigger was v1.0.3, the name of this trigger in the execution history will be deploy to Google Play space hyphen space v1.0.3 to be easier for revision. Okay, the fourth line here, we set the permissions content right to give this workflow a permission to create a commit in our repository if our workflow needs to edit our repository code. Here we give it the permission to create a get commit and push it to our repository effectively. And the next line, concurrency group deploy to play GitHub ref and the cancel in progress equal true. Here we configure this workflow to disable running concurrent instances of this workflow. So if we have an instance of this workflow running and we called another instance, the second instance will cancel the running instance to avoid deploying multiple versions of our app to the Play Store. And on the number line, to the line number 11, we configured the trigger of this workflow to be on push tags started with the asterisk to execute this workflow immediately when we push a tag started with a small v. And in this slide, we create a job named test and configure it to run on the latest version of the Ubuntu operating system. Then we add a step to check out the repository and fetch the commits from the Git history. We set fetch dips to 0 here, as I mentioned before, to fetch the entire history of our Git history, fetch all the commits. After that, we add a step to set up Java. GitHub Actions has official actions that make this easy. So the action here, set up Java at v4, it's a pre-created action and it's official action created by GitHub. His name is setup -Java, and we specified the action version that help us to avoid issues where some issues represent in an update of an action. So we stick with a specified version that works efficiently with us. And using with keyword here, we added arguments to this action. So we configured the distribution of this Java version, and we set it to Temurin. It's the Eclipse version of OpenJDK, and also we set the Java version to 21. Take care here to configure the Java version to be matched with the Java version you depend on your project to avoid conflicts while running the workflow on your runner. If you configure, for example, if you configure your project to run on Java 21 and to configure the workflow to run on Java version 17, that may cause some conflicts while running your workflow. So take care of that. Next, we cache Gradle files to speed up build process. As I mentioned earlier, you have a free quota for private repositories. So spend them effectively and efficiently. So you can use the cache to speed the build of your workflow and running your workflow to save some time of your free quota. After that, we need to grant the execution permission to the Gradle wrapper using this terminal command chmod +x Gradle w that represents the Gradle wrapper. Then run the unit tests with a terminal command /Gradle w space test. This command is responsible for running your unit tests in this project. Notice that when we need to run a terminal command, we use the keyword run, while using the keyword uses before to use a pre-created GitHub action. Once that works, we move to signing the app. We upload our key store file as an encrypted GitHub secret along with passwords. Inside the workflow, we decode the encrypted key store and use it for signing. I have attached a repository at the end of our session. This repository contains also a code lab that teach you a step-by-step to create a look-like GitHub workflow like this one, and take you step-by-step to create your service account, Google service account, and also how to encrypt your key store file as base64 string to store it in GitHub secrets. And this step, we did it before we decrypt this key store here. So this is the reverse process of our encrypting step. Note that we used the keyword leads, as I mentioned, to configure this job to depend on the test job. So it waits until the test job finishes successfully. And if the test job fails, the deploy job will not be executed. I mean, here we defined this test. Okay, I mean, we defined here this test job, and later we configured this step to with needs test. So this step depends on the success of the test step. So if the test step finishes successfully, this step will be triggered automatically, and if the test step will be canceled or failed, this step will not be triggered anymore. You may notice that we used the steps in this slide in the previous job, which named test. That's because jobs in GitHub Actions are isolated, and you can configure them to work sequentially or in parallel. As you see before, we configured the build or here. Yeah, the distribute step to depend on the test step. So here we choose to run them sequentially. And if you have multiple steps that there is no requirement for them to run sequentially, there is no dependencies between each other, you can run multiple steps in parallel to save your time. After signing, we generate an artifact, the APK or bundle, so we can upload it to the Google Play console. You can also follow this approach and depend on community upload action to bump the app version. In this example, I used the number of running times here, the GitHub dot run number. I use this variable that represents the number of running times of this workflow as the version code, and the variables named ref underscore name that represents the trigger of this workflow. As we mentioned, maybe v1.0.5 or v1.0.3. So here we use that trigger as the version name for our APK or our bundle while we upload it to the Google Play Store. So it will be the name of the trigger itself. For example, as I mentioned, v1.0.5. Also, you may notice that there are some actions that starts with, for example, here, actions slash cache. Here that represents a pre-created action, but this action is official from GitHub Actions. And you can also use a community published action like this one here that starts with the name of the developer. This is a community published action. Okay, if you want automatic internal testing, you add the Play Store upload step using this community upload action. That is how you make the full cycle automated. Starts from code, build, test, sign, and finally upload your artifacts to the Google Play Store. This workflow is reusable, scalable, and easy to maintain. Once it's set up, your team never has to manually build or upload your artifacts again. To make your pipeline faster and more powerful, you can use caching. Caching Gradle dependencies and Gradle configuration can reduce build time from minutes to seconds. A simple cache step can dramatically speed up your workflow. I want to mention a story with you. It's a personal story. One of the projects I am working on, we started it as a uni model project. We have only a single Gradle module for the project because it was small at the beginning, and gradually sorry for that, the build time and it reaches about 40 minutes if you run the project for the first time on your device. So we decided to split our project to multi-module project. So we choose modularization. We created a separate module for the core modules like core domain layer, core UI layer, and the core data layer. And also we split each feature in a module. So we also choose modularization by feature. And that help us to reduce the build time to about 15 minutes. So we cut the build time to the half, and it was a great step. But Then we learn how to configure Gradle and use Gradle cache. We cache Gradle configuration and the Gradle dependencies. We learned how to do that, and that reduces our build time. So if you now we're working on this project, our build time for the first time it's about from 12 minutes to 15 minutes. That's for the first time. And after caching the dependencies and the configuration, the build time reduces to just 18 minutes. Can you imagine that? From 18 seconds. Can you imagine that? From 15 minutes to just only 15 or 18 seconds. It was a big success for us, and we can't believe that at the first. So the caching is a major step and the crucial step you can depend on to reduce your project's build time, and also it helps you to reduce your workflow running time, so you can save your free quota, or after reaching the free quota, if you choose to subscribe to a paid plan of GitHub Actions, it also will help you to reduce your bill, your costs of running your workflows. So it's a crucial step you have to use it. Also, you can use metrics builds. You can test multiple versions of Android, multiple versions of Java, or different build types in parallel. That also helps to reduce the workflow running time. Parallel jobs also is beneficial. You can run lint, unit tests, and integration tests at the same time. Each step of this doesn't depend on each other, so you can run them in parallel and save your time. This reduces the total pipeline time. Also, self-hosted runners. If your project is large, or you need a special hardware, or you can run your own machines, Linux, Mac OS, or Windows device. This is popular for big teams and performance critical builds. It's also used as a solution to overcome the 2,000 minutes monthly limit created by GitHub for private repos in the free plan. If you want a real hands-on experience after the event, after the session, you can clone the repository, run the workflows, try different triggers, break things, and fix things. CI/CD becomes intuitive when you experiment. Here are all the resources you need: Android docs, GitHub Action docs, the MyTasks repo, and a full code lab that walks you step by step through the entire workflow. Feel free to connect with me to give me feedback about this session, or to ask for the slides or any something. I love to hear feedback from you. I share a lot of tutorials, code samples, and automation tips. So today, we covered how to build a complete CI/CD workflow for Android using GitHub Actions. We automated build, test, signing, and deployment, and we made sure everything stays secure. CI/CD helps you ship your apps faster, with more confidence and less stress. Also, in the attached code lab, you will find the steps required for securing your app secrets using GitHub secrets. You can how to add them to your GitHub secrets in the repository in the settings section of your repository. Thank you so much for joining, and let's automate together and ship it faster. Thank you. Hello, Lisa, if you're here.